In the last video we decided to open our boat's rudder up so we could inspect the stainless steel stock and frame inside, and unfortunately we uncovered a bit of a mess. So we stripped the two halves back to solid fiberglass, cleaned up the stainless, and the area where there was some damage has now been repaired and reinforced. We're now just about ready to start laying up the new fiberglass to build up and strengthen the inside of the shell. We've already prepped and sanded the inside, and I'm giving it a quick clean with the vacuum cleaner to get rid of any dust and particles, and I finally go over the whole thing with the adhesive side of some masking tape to try and get rid of any persistent bits stuck to the fiberglass. I'm starting off by wetting out the whole area with an unthickened epoxy resin mix. It depends on how porous the material is, but for an initial thin coating layer on top of cured fiberglass like this, 100ml goes quite a long way, and you should expect to get about 1 square metre of coverage. So for this half of the rudder, I've only needed to mix 150 grams to be able to get it fully wetted out. As you've already seen in the last video, I've pre-cut all the fiberglass matting I'm going to be using, and so I should be able to work quite quickly and get both halves done today. I've ended up having to remove an unquantifiable amount of material from the existing shell, so I've not factored that into my calculations regarding the overall structural strength of the finished rudder. So, how did I decide on how much fiberglass to use and how to orientate the weave of the cloth for the layup schedule? Well, ISO are design standards for fiberglass rudders on small craft, so I initially referred to these. After rechecking my calculations several times, this seemed like an eye-wateringly little amount of material, but as a minimum standard's just that, a minimum, and after digging into it a little bit deeper to check out some possible impact forces, I ended up exceeding this by almost a factor of 4 in my final schedule. I'm using a combination cloth on the first layer with the chopped strand mat inside underneath, and this should bond better with the existing fiberglass. I'll then be adding alternating layers of cloth to build up the strength in each of the 45° and 90° axis. Here I'm using an equal weight ratio of epoxy resin to fiberglass cloth, and this balance works well for both weave types of cloth I'm using. I want to use just enough resin to fully wet the cloth out. Once I've worked it in with the roller and got rid of all the air, I'm aiming for a minimum of residual resin, as any excess will actually weaken it overall. Working on quite a large area like this, I'm just adding one layer at a time, and you can quite easily see if the matting's fully absorbed the resin or not, as there's a distinct colour difference between the dry and the wet cloth. The way I'm putting this back together, I'm just using the pre-existing shell as a moulding former for the shape and the size of the rudder, and effectively building a new rudder around it. The old shell will still be enclosed within it, and it will give some structural support, but the majority of the strength will be in the new layers of fiberglass that I'm building up now. Once I've added all the layers that are required for the layup schedule, I put a sheet of peel ply over the top. If you've never used it, peel ply is a tightly knit nylon cloth that does two jobs. It traps the waxy layer of amine blush that develops on the top of the epoxy when it's curing, and if you don't do this, it needs to be washed off with warm water before you can bond any further layers of epoxy or other material to it. Also, once the epoxy is cured and you remove it, it leaves a finely textured surface and so removes the need for further sanding to create a key to be able to bond to it. So if you're able to use it, it's well worth the effort of applying over the top of the last layer, as it makes things much quicker once the epoxy is cured. You need to make sure that this is fully wetted out too though, or any dry spots won't trap the wax and it'll need to be washed and sanded when it's cured. But because the cloth's very thin, I've never needed to add any more epoxy to do this. I've now peel plied the fiberglass and laid the rudder stock on top. This is sat on the original tabbing points I cut it out from. I've done this as I'm a bit worried that as the rudder's open, it has no torsional stability to be able to hold its shape, and that it might cure slightly warped. So my aim here is to try and make sure that as the fiberglass hardens, it doesn't twist. As I lay the stock on top of the rudder shell, I raised this part of the stock off the bench with a wooden block, and cantilevered the other end using a ratchet strap attached to the bottom of the table. This has removed all the weight from resting on the shell, and what I've done is raise the shell up to it by resting it on wooden blocks, and then clamp the stock and the frame to the fiberglass, and hopefully reduced any chance of it warping or twisting. You can also see how I've used some grey pipe lagging and a few more clamps to stop the vertical edges from drooping. And then we're ready to repeat the process with the other half. The following morning after it's cured, I remove the clamps and slide the shell out from underneath the stock, and you can now see how it's suspended and none of the weight was actually resting on the shell. It's an easy and satisfying job to remove the peel ply, and now we've got both halves refiberglassed inside, we can start to trim them up and get them ready for fiberglassing the rudder stock in and fitting them both back together again. I'm using the multi-tool again to trim the excess fiberglass, cutting along the original edge as a guide. So now you can see the finish of the layup, and though it's far from perfect, there are no dry spots or air pockets that I can see, so thankfully there's nothing that looks like it needs fixing or redoing. There are a few patches where the peel ply didn't quite stick properly on this half, and these will need washing and sanding before we close both halves up and add the expanding epoxy foam, but they're only small patches so it'll be a quick job to do. As we've now built up material on the inside of the seam on the trailing edge, the top half's not going to sit flush to where it was originally cut from, so I'm going to remove this new fiberglass and at the same time create a lip for the top half to sit on. So I take a measurement of the new thickness of the top part of this shell, and luckily this is the same size as one of the guides that I already have for the multi-tool. And then using this guide, I cut along the seam of where the new meets the original fiberglass, and then remove the strip of epoxy fiberglass to make a lip that the top half will sit perfectly flush on. Now it's trimmed up, I can actually fit the two halves back together and see how they're going to fit. I mark up and cut out the other half of the radius for where the rudder stock's going to sit in the collar. I didn't want to try and do this earlier, as I wanted to make sure that the fit was as tight as possible, and hopefully by doing it this way it ensures that. I'm going to be filling this collared area with 3M's 5200, and this should make for a very strong watertight bond and seal the whole of this area. Though 5200 does set with a certain amount of flexibility, I'm adding a beaded butyl tape here to allow for the expansion and flexion during the rest of the build process, and also for once the rudder's refitted to the boat. The thinking behind this is that as butyl tape doesn't set, it'll hopefully form a small soft seal that won't break free from between the stainless steel and the fiberglass. We've now got the rudder stock in that same cantilever arrangement as we had before, though I've raised it up a little bit this time so I can work underneath it a touch easier. And I'm starting to put down some more thickened epoxy on those tabbing points that we're going to be dropping the stock and laying it onto. Once I've got all the filler I need on the tabbing, I lower the stock into position using the buckle on the strap, and I try and get it something like level. Once I've dropped the frame to where I want it, I then use the same wooden wedges as before to lift the shell up into position and then clamp it down again. I'm starting to fill in all those gaps and cavities around the frame and the stock, creating fillets along the edges so the next layers of fiberglass all lay over this nice and smoothly. Okay, so all the areas we're going to be laying more fiberglass on are now filleted, and I'm just going to leave it a couple of hours to start to go off and firm up a little, as I don't want to squeeze it all out as I'm laying the new matting on it, but I still need it tacky so it'll bond properly. When they originally put the rudder together back in 1987, they fully bonded every part of the stock and the frame onto the shell, and so even though the rest of the inside was a bit of a mess when we opened it up, this part of the construction was actually done quite well, and it made for a very strong and stable structure. It did mean that by doing it this way, it created internal chambers between each part of the frame, and then when it came to fill it with foam and resin, that's when it all went horribly wrong. So what I've decided to do is to bond the stock on the frame, but leave the armatures of the frame exposed, and when we come to add the foam, we'll be able to pour it in down from the top, and hopefully it'll be able to flow between the holes, and we'll be able to fill it without leaving any gaps this time. And here we are, with the stock now rebonded to the shell. The shape here is pretty irregular, and I didn't bother to try and put peel ply over it this time, as the stuff works best on flat or gently curved areas, and I was pretty certain it would leave far too many patches that would only need cleaning up anyway. I'm just making sure that the beaded butyl is sealing the gap between the stock and the fiberglass on this half, and is formed around the collar and ready to go for the top half. I've already applied 3M's P592 metal primer around the stock and let this dry, and I'm using their 5200 sealant for filling this space on both halves. I purposefully left one side open, so when I close it up, any excess will push out into this side. I've already used more thickened epoxy to bulk out the bottom to create a solid surface for the top to sit on. Now I've just added a further thick bead all the way around the edge, and this is going to be used to seal the two halves together. I filled the top half with the 5200 and then we're ready to go to get it into position. This is the fast cure version of the product, though don't be misled by that as a description. As with all sealants, the curing time is dependent on the thickness of the application, and this stuff takes at least 48 hours to cure a very thin bead, and so a large area like this is going to take weeks to fully cure. With a helping hand from Carl, we put the top part on, and miraculously it all actually fits how it should. There doesn't appear to be any distortion on either of the halves, and the edges sit back together nice and flush. We clamp both parts together while being really careful not to put too much pressure on and cause any unintended deformation. We ran out of clamps to be able to hold it down in all the areas that I wanted to be able to secure, so we used a glue gun to glue some wooden blocks to the fiberglass. In hindsight, I probably could have used this technique for all of it, as it holds everything nice and flush and there's no pressure squeezing on the shell, unlike using the clamps. And this is it, back together, looking something like a rudder again. It's stood up and we're all ready to start to mix the expanding epoxy foam. Before I sealed it up, I drilled a 25mm hole in the top, and this is where we'll be pouring the foam in from. As you can see, there's plenty of space around the frame, and the liquid foam should flow freely past it to get to the bottom of the rudder, and we should be able to eliminate any voids. There are a couple of options of expanding epoxy foam on the market, and I ended up going with Sicomin's PB250 resin in combination with the DM02 hardener. Sicomin produced 4 different density versions of this resin, and the 250 in the title refers to the overall expanded density of the product in kilos per cubic metre. This simply means that this version expands to 4 times its original volume once it's mixed with the hardener. They also do 2 versions of the hardener, this one being the slow setting version. As I'm going to be filling a reasonably large volume in one pour and the ambient temperature is quite warm, the fast hardener would get too hot while curing and it would potentially burn. I checked that the ambient temperature and the humidity was within the working range of the product and thoroughly mixed the resin before pre-weighing everything out into containers. The reasons I ended up using this product were that the West System version that I was considering wasn't available anywhere at the time, and West couldn't tell me when it would be back in stock. Also, Mads from over on the channel Sail Life, he'd already done some really great research and testing of the foam's expansion speed and pressure, and this was really useful to be able to see beforehand. I also wanted to be able to post-cure the rudder once it was set, to be able to maximise its strength potential, and the Sicomin foam has a considerably lower post-cure temperature than any of the other products that I could find, which made it much easier to be able to get it up to that temperature for the required amount of time. The datasheet says the working time for the foam is 4 minutes, but after mixing a small sample up, I found this to be a bit optimistic. At 21 degrees centigrade, I barely got 3 minutes from the moment I added the hardener to the resin to the point that it became too thick to be able to pour through the funnel, so you certainly need to work fast. I weighed it all out into 6 separate mixes, so I had enough time to get each batch through the funnel before it all expanded too much. And as recommended, we passed each mix through a fine mesh sieve to try and eliminate any little bubbles we created during the mixing. As you can see, the foam expands very slowly, and therefore there's a minimal amount of internal pressure on the shell as it fills up, as the last thing I wanted at this stage was it deforming or even splitting open. As when using all epoxy, you need to be careful with the volume you're mixing and applying. When epoxy cures, it creates heat, and the greater the volume of epoxy, the higher that temperature can become, and if it gets too hot, it's going to become damaged, or even get to the point where it can combust. Sicomin provide info on these expected exothermic temperatures, and at its widest, our rudder is narrower than the maximum recommended thickness, so this shouldn't pose a problem. Once this had cured overnight, we started to clean the outside and get it ready for its final wrapping. I ground a 12-in-1 bevel around the hole used to fill it up, so I could build up the layers around it, and tidied up the area around where the stock enters the shell. Carl gave us use of his forklift truck and helped us move it into position so we could finish cleaning it up and start laying that final fiberglass down. We used a lifting strap around the neck of the stock and another one on the lifting eye at the top of the rudder, and again used the cantilever idea so we could hang it up and keep any weight off the fiberglass.
Miles's face is the I know, Miles's face is the funniest. Yeah. I know. Doesn't have to be much at the minute, does it? No. It's just a bit. 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 It's just a bit
I started off by laying some long strips of matting along the leading edge of the rudder, with the aim of strengthening the bond between the two halves here, and also to try and build up and increase the radius of the curve, as the original rudder profile was pretty flat. Rudder design profiles are readily available to download, and I originally wanted to be able to use one to create a template to be able to fare the rudder and achieve an efficient shape. But after checking this shape against all of the NACA foil profiles that were anywhere close to it, I abandoned the idea, as the discrepancy between this and any other profiles was just too large. And so, without going down a big rabbit hole of an explanation here, one thing I did learn while researching this is that the current angle just didn't comply with any of the calculations of chord length, pitch and attack angle that rudders are now designed to. So I ditched the idea of trying to use the foil profile and resorted to using a Mark 1 eyeball to try and get that leading edge radius looking something like what I wanted to try and achieve. For the first layer I used a thin piece of chopped strand matting this time, as the combination mat was too thick and it wouldn't drape over the trailing edge properly. We continued to build up the next few layers with the same combination of woven fiberglass before wrapping the whole thing in peel ply and leaving it to cure overnight. After a little more work around that neck area the next day, we're just about done and ready to head back to the boatyard.
Watch the next video as we head back to the boatyard to post-cure the rudder and we uncover some pretty serious problems around the rudder bearings.